Radical polymerisation is the mechanism by which we make addition polymers. So I am thinking of polymers like polythene or polyethene, polyvinyl chloride, polystyrene, which are all polymers that I'm sure we have heard of. The example I'm going to work with is the production of PTFE, polytetrafluoroethene, which is more commonly known as Teflon, our amazing polymer that was discovered completely by accident, this happens a lot in chemistry, in the late 1930s. So polytetrafluoroethene is made from the monomer fluoroethene, or tetrafluoroethene. So we have carbons, double bond, and instead of hydrogens and ethene, we've got 4 fluorine atoms. And what we find is if we take a large number of those and polymerize them, we end up with a polymer that looks not unlike polyethene, but obviously with fluorine atoms in the place of hydrogen. So that is my monomer, and this would be the repeat unit of my polymer. So how did we actually get from monomer to polymer? Because at GCSE we kind of just said we cracked open the double bond and we slotted them together. However, the actual mechanism is far more interesting. So now that we know about radicals, let's have a look at that. So the reaction, being a radical substitution reaction, happens again by initiation, propagation, termination. So in the initiation, we have got initiation, yes, I have spelled that right. We have the reaction of ultraviolet light on a peroxide. A peroxide has got a single OO bond in it, and this bond is very weak. The R groups here, this is an organic peroxide, so organic peroxide, are alkyl groups. So that means it could be a CH3, for example, or a C2H5. So we have got action of UV light, so high energy ultraviolet light. We're going to get homolytic fission of the OO bond, so splitting it up to form radicals, so RO, and we're going to have 2 of those. So that is the radical that's going to initiate the chain reaction that turns our monomers into polymers. So in the propagation steps, So a propagation step is where we start off with a radical and end up with a radical. We're going to take our alkoxyl radical, this is its official name, alkoxyl radical, and we're going to take a monomer. So here is our tetrafluoroethene, and we have a bond formed between the oxygen and a carbon using one of the electrons out of the pi bond, out of the double bond, and then the second electron is left on the carbon. So what we end up with is RO. We've got a new bond formed between the oxygen and the carbon. The fluorines stay in place. That double bond is now a single bond because I've used one of the electrons to make this new bond here, and the other is sat on the carbon. So we've got a chain reaction going on, and hopefully we'll be able to see that next step we would have fluorines, carbons and fluorines, and that will bump into, because we're going to have a high concentration of the tetrafluoroethene, to form the next step in the chain. So carbon, 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 fluorine, 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 and so on. So this is a common mechanism for the formation of addition polymers, and it's a radical mechanism using an organic peroxide to initiate the reaction. If this has been useful, hit the subscribe button, the effortless way to support your studies. And by clicking the link in the blurb below, it will take you straight to the Crunch Chemistry School, where you'll find all the resources you need to get that A-star grade at A-level. Together we can do this.